Hi, my name is Trevor. Today we're looking at chapter number 5, or break-even analysis, or CVP analysis. Our chapter learning objective, the lead outcome is we should be able to analyze short-term pricing and product decision. So it's key to understand that we're looking at only short-term pricing and product decision, not long-term. Then the component is we need to apply break-even analysis in multi-product context. So we want to be able to apply our break-even analysis when we have more than 2 products. So break-even analysis is part of a section that covers decision making. So in management accounting, we're concerned with 3 things. Either we're looking at planning, we're looking at control, or we're looking at decision making. On chapter number 5, we're looking at decision making. So the first thing is we want to look at what is CVP analysis, or what is break-even analysis. So basically what CVP analysis is, we're looking at how do costs, volume affect our profit. How do costs, volume affect our profit? So it's CVP analysis, or cost, volume, profit analysis. So we'll be looking at what happens if we change our cost, what happens if we change our volumes, what effect does it have on our profit. But before we look at that analysis, we need to first make certain assumptions. And our assumption for CVP analysis, the first assumption is our sales price remains constant. And the second assumption is costs are linear. So our first 2 assumptions here are not realistic. In the business world, rarely is selling price constant. So selling price can be affected by external factors, or it can be affected by internal factors. Example is, if our cost of the product increases, then we also need to pass it to the customer. So we need to change our selling price. Or if our competitors adjust the selling price, if they lower their selling price, then as a company we also need to lower selling price to remain competitive. Then the third assumption is we assume activity is in the relevant range for fixed costs and variable costs per unit to remain constant. When you looked at the first topics, absorption cost and marginal costing, you defined your fixed cost and your variable cost. We said our fixed cost, these are costs that do not change in total. So our fixed costs are costs that are constant in total. But then we went on to say that this is only true within a relevant range. So that's what that assumption is saying activity is in the relevant range for fixed costs and variable costs per unit to remain constant. Because if we're outside the relevant range, our fixed costs might step up, they can change. The same applies to variable costs. If you're outside the relevant range, our variable costs might fall. For example, when you get quantity discounts, your variable costs might fall. But here we have to make an assumption that activity is in the relevant range for fixed costs and variable costs per unit to remain constant. Then the fourth assumption, its sales mix remains constant. Now what that means is we are assuming that the proportion that we sell our products in is going to remain constant. So an example is, if for every 2 units that we sell of product A, we expect to sell 5 units of product B and maybe 3 units of product C. We're making an assumption that we are assuming that this proportion is going to remain constant. So we say our sales mix remains constant. So those are our assumptions. Then our assumptions are also going to become our limitations, because these assumptions are too simplistic and they're not realistic. But for us to apply this break-even analysis for short-term decision making, we have to make these assumptions. The reason why we cannot use break-even analysis for long-term decision making is, in economics, in the long run, all costs are assumed to be variable. So even fixed costs, we assume that they're going to be variable in the long run. So for short-term decision making, we assume that fixed costs, they're only going to remain fixed. So we can apply them for short-term decision making. So it's very important to understand our assumptions. Then the decision that we want to make here is, the first decision we want to look at is, how many units must be sold to break even? The second one is, how many units must be sold to achieve a target profit? The third one is, how profits be affected if any variable changes? Then the fourth one is, how will profits be affected if we introduce a new product or service? So those are the decisions that the company will be trying to make. So that's what we're going to cover in our CVP analysis. So our starting point here is going to be the break-even point. We want to calculate the break-even point in units. So first we have to understand what is the break-even point. Our break-even point is a point when our revenue is equal to our total cost. So we're going to break even as a company if our total revenue is equal to total cost, which means the company is not making any profits, the company is not making any losses. The revenue is sufficient enough to cover the cost. Now our aim here, want to find then, how many units do we need to sell in order that our total revenue is equal to our total cost? That's what we're trying to find out. And to get to our total revenue, we know that we need to sell X units times the selling price per unit. That's how we get to the total revenue. So aim here, we want to know how many units should we sell such that our total revenue becomes equal to total cost. Our total costs are made up of fixed costs and variable cost. So we say if we sell X units at a certain selling price per unit, then our fixed cost will be equal to our variable cost. Our variable cost, our total variable cost here, we take X units times variable cost per unit. So our aim here is to find this number of units that we call in here the X units, to say how many units do we need to sell such that our total revenue is equal to our total cost. So what we have to do with this formula is we need to make X the subject of the formula. To make X the subject of the formula, we need to bring this bracket to this left hand side of the equation. It becomes X times selling price per unit minus X times variable cost per unit, and this should be equal to our fixed cost. Then the X here is a common factor, so we can take X out of the bracket. It becomes X selling price per unit minus variable cost per unit. This should be equal to our fixed cost. Then now, since on this side now we have the X variable, we just have to remain with the X variable on the left hand side of the equation. We need to divide both sides by selling price per unit minus variable cost per unit. Variable cost per unit. Now selling price per unit minus variable cost per unit cancels out. Then we're saying to get this X units, it's equal to the fixed cost divided by selling price per unit minus variable cost per unit. So that's how we can find our units, the break-even point. So here I'm just trying to show you where the formula comes from. So the formula comes from the fact that our revenue has to be equal to our total cost whenever we break even. So we're trying to find these X units that we need to sell to break even. So in your exam, you're not required to come up with the formula. The formula, you just have to remember the formula that to calculate your break even point, it's your fixed cost divided by selling price per unit minus variable cost per unit. But it's very important to understand the theory that the units that we're trying to calculate here are the units that we need to sell so that our revenue is equal to our total cost. So here we just saying our break-even point in units is equal to fixed cost divided by what we call contribution per unit. When you looked at marginal costing in your chapter number 1, you looked at the concept of contribution per unit. So contribution per unit, it's selling price less variable cost per unit. We call that contribution per unit. So the formula is just selling price per unit minus variable cost per unit. But we need to understand what contribution per unit is in words. If you are to describe to someone, to explain to someone what is contribution per unit. Now contribution per unit is the amount generated by an individual unit that will be used to cover the fixed cost. So saying contribution per unit is the amount generated by an individual unit. That amount we're going to use it to cover the fixed cost. Then once the fixed costs are fully covered, it becomes profit per unit. So that's the definition of contribution per unit. Saying this is the amount that is generated by an individual unit. That amount we're going to use it to cover our fixed cost. Because since we said contribution per unit, it's selling price per unit less variable cost per unit, which means already we have removed our variable cost. So the only cost that is left to cover is our fixed cost. Now once we have covered the fixed cost in full, it starts to become profit per unit because we have fully covered the fixed cost. So we call that contribution per unit. So whenever you want to calculate the break-even point in units, you take your fixed cost divided by contribution per unit. So that's the formula for break-even point in units. We're going to look at questions a bit later, but we just want to first go through all the concepts. Then in some cases, the examiner will require you to calculate the break-even point in revenue. So break-even point in dollars. To calculate our break-even point in dollars, we take our fixed cost divided by the contribution to sales ratio. So that's one way of calculating the break-even point in dollars. Another way of calculating the break-even point in dollars is first you calculate your break-even point in units. Then you multiply with the selling price per unit. You have converted your units to the dollars. Or you can take your fixed cost divided by contribution to sales ratio. Our contribution to sales ratio is calculated by taking your contribution per unit divided by selling price per unit, or taking your total contribution divided by total sales. So both the formulas give you the contribution to sales ratio because it's a proportion. Whether you calculate it based on individual units or in total, you're still going to get the same answer. So you can express it as a percentage or you can express it as a decimal. But we need to understand in words, what does this mean? So for example, if you've calculated your contribution to sales ratio and it's 20% for A, then for B it's equal to 30%. Now what this means is, for every dollar of sales, the company or the product generates 20 cents in contribution. Then for every dollar of sales, the product here is generating 20 cents in contribution. That's for A. Then for B, it means B is generating 30 cents in contribution. And we said the contribution, we are then going to take it to cover our fixed cost. So here it means that B is a better product because it's contributing more per dollar of sales. So we are able to cover our fixed cost faster because we're getting more contribution from product B than we are getting from product A. So the contribution to sales ratio is very similar to what we call the gross profit margin, where we're calculating for every dollar of sales, how much is gross profit. The only difference here, we're saying for every dollar of sales, how much is contribution. The contribution, we're going to use it to cover our fixed cost. So the greater or the higher the contribution to sales ratio, the more profitable the product. It means that we're able to cover our fixed cost much faster. Then the other name for this contribution to sales ratio, it's also called the contribution margin. It's called the contribution margin. So I just mentioned that the contribution to sales ratio is similar to the gross profit margin. Whenever we use this term margin, for example, like how we used it here, contribution margin, we're comparing contribution to sales. The same applies to gross profit margin. We're comparing gross profit to sales. Net profit margin, we're comparing the net profit to sales. So in the exam, the examiner can tell you that the contribution margin ratio is 20%. Then you know that this is the same as saying the contribution to sales ratio. The moment that we mention the term margin with another verb before it, then it means that we're comparing this verb with the sales. So it's comparing the contribution or the noun with the margin. So we're comparing the contribution with our sales. So contribution, we said, is the amount that we use to cover the fixed cost. Once we have covered the fixed cost, it becomes the profit. So this is the concept on break-even point in dollars. And the next concept that we're going to look at before we start looking at questions is companies do not only operate to break even. Companies operate to make profits. So we should be able to calculate units required to achieve target profit, as well as calculating revenue required to achieve target profit. On units required to achieve target profit, now we want our contribution per unit to cover both the fixed cost as well as the target profit. So here the formula is almost similar to our break-even point in units. But on break-even point in units, our contribution was only going as far as covering our fixed cost. But now our contribution is fully covering the fixed cost, and it's also making a profit. So we want to find out the units required to achieve the target profit. Then with revenue required to achieve target profit, it's going to be fixed cost plus the target profit divided by our contribution to sales ratio. Because already we talked about break-even point in revenue, we have to divide with the contribution to sales ratio. So it's very important for companies to calculate their break-even point as well as the units required to achieve target profit or revenue required to achieve target profit. Now the question is, why is it important for short-term decisions? The reason why it's important is, before a company even starts, the company needs to understand when are they going to break even? How long is it going to take them to break even? So that analysis begins with first identifying how many units do we need to sell to break even. So before you start the business, you calculate that your break-even point in units, say maybe it's 10,000 units. Now the company has to ask itself, or the managers have to ask themselves, how long is it going to take us to sell the 10,000 units? Maybe it's going to take you 7 months. Then you can make a decision, do you want to continue with the operations or not? So in some cases, breaking even might actually take years. So in those cases now, you need to talk to your shareholders and say, we're going to take 4 years before we even break even. Now, are you fine with that? Do you want to invest your funds in the company? So it's a starting point. You want to know how long is it going to take you to break even. So once you calculate the break-even point here, you need to take the information, give it to the relevant people that can use it. An example is, you take the break-even point, you give it to your marketing department, your sales department, your advertising department, so that they know that any campaign that they have to undertake, the aim is, first we need to break even as a company. We first need to sell 10,000 units. So they need to find ways of selling the 10,000 units. Then we also need to look at the units required to achieve the target profit. Maybe to achieve the target profit, we require 15,000 units. The information also has to be communicated to the relevant people that have to make the decision. Say, okay, if we want to achieve target profit, then we have to sell 15,000 units. They have to place measures to sell the 15,000 units. So they talk to the salespeople, they go and try to see, can they market more, or can they look into entering a new market so that they increase their units that they're going to sell. So all that now is happening decision making. So this is not only a computative aspect. Once you calculate the break-even point or the units required to achieve target profit, then it has to be used in short-term decision making. So managers have to make decisions. Should we continue with the product? Should we stop the project? Is it contributing enough to cover our fixed costs? Is it contributing to covering our profit? So that's basically your break-even point and the units required to achieve target profit. Now what we're going to look at now is, we now want to look at some questions. We're going to look at the computative aspect. Our first question is example number 1. So in chapter number 5, you go to example number 1. So the textbooks are a bit different, the 2015 and 2016, so the page numbers might be different. But in my book, it's page 172, example 1. So in example 1, we're going to do the part 1 and the part 4 for now. In the exam, how you do it is, first you have to read the requirement. So the requirement says, calculate the break-even point in sales unit per month. So we want to find the break-even point in units. We said we need to take our fixed cost divided by our contribution per unit. So writing the formula down will help you. Now once you have the formula down, you have to go identify the fixed cost, identify the contribution per unit. We told that a company manufactures and sells a single product that has the following cost and selling price structure. Given the selling price and we're given the cost per unit, then the fixed overhead absorption rate is based on normal capacity of 2,000 units. So in our absorption costing, we looked at calculating the overhead absorption rate per unit. So how do you calculate it? You take your budgeted fixed production overhead divided by the units. That's how you get your overhead absorption rate per unit. So here we're given our fixed overhead absorption rate per unit is 12 based on a normal capacity of 2,000 units. So we need to identify the fixed production overhead. Our overhead absorption rate is given, so here let's call it X. Then our number of units is 2,000 units. And the overhead absorption rate per unit is 12. So we have to get our fixed production overhead. So you make X the subject of the formula, our X becomes 12 times 2,000. Means our fixed overheads are therefore 24,000. So that's the first part. So our fixed costs are 24,000. Then we need to calculate our contribution per unit. So to calculate our contribution per unit, we take our selling price per unit, which is 120, minus our variable cost. So variable cost is 22 plus 36 plus 14. When you looked at absorption cost and marginal cost, you looked at what we call direct cost. All our direct costs are variable cost. So direct material is a variable cost, direct labor is a variable cost. Then we need to include variable overheads. So it's 22, the 36, and the 14. So we get a total of 22 plus 36 plus 14. Means our variable cost in total, they're 72. Then we say 120 minus 72, which is 48. So we're taking 24,000 divided by 48. So 24,000 divided by 48. So our break-even point in units is therefore 500 units. So that's how you calculate your break-even point for a single product. You use your formula, it's fixed cost divided by contribution per unit. Then you have to first of all identify the fixed cost. So here we're talking about the total fixed cost because we want to cover all the fixed costs. Then we're given that the fixed overhead absorption rate per unit is 12, that is based on 2,000 units. So we have to use our formula of overhead absorption rate to calculate our fixed cost. And our contribution per unit is our selling price less our variable cost. That's how we get the 48. Now break-even point in units is 500. Now had the question said calculate the break-even point in dollars, we would have done it differently. So if it's break-even point in dollars, it was going to be fixed cost divided by the contribution to sales ratio. Our fixed cost would still get the same amount, which is 24,000. But now our contribution to sales ratio, we take our contribution per unit divided by selling price per unit. Our contribution per unit, we got it as 48 divided by selling price per unit, which is 120. So we take 48 divided by 120. 48 divided by 120. That's 0.4. Basically, it's just our 24,000 divided by 0.4. So if you're using a calculator, you can just take your 24,000 divided by 48 divided by 120. You get straight to the answer. So here I'm just going to first convert it. Then I say 24,000 divided by 0.4. You get $60,000. So we're saying in order to cover all our costs, we need to generate $60,000 in revenue. That's how we're going to cover our fixed cost. Or we need to sell how many units? We calculated and we got 500 units. So that will be our break-even point in units and in revenue. Now how we could have got to the 60,000 here as always? Since we know that our break-even point in units is 500 units. And each unit is sold at $120. We could have just taken the 500 times the 120. Would still get to $60,000. So it doesn't necessarily mean that if the question says calculate the break-even point in dollars, we have to use this formula. You can calculate the break-even point, get it in units, then convert it from units to dollars. Or if the question says calculate the break-even point in units, you can start by getting it in dollars. You divide with the selling price per unit. You also get it in units. So that's how you calculate the break-even point. So that's requirement 1. We're also going to look at requirement 4. Now requirement 4 is saying the sales required to achieve a profit of $96,000 in a month. So we now need to know how many sales are required to achieve a profit of $96,000. So we want to calculate the revenue required. So we take our fixed cost plus the target profit divided by your contribution to sales ratio. Our fixed costs, we got them as 24,000 plus the profit that we want to generate, which is 96,000. We divide this by 0.4. So 24 plus 96,000, that's 120. We take 120,000 divided by 0.4. The company needs to generate revenue that is equal to $300,000 in order to make a profit of 96,000. That's how you calculate revenue required to achieve target profit. Now, we not only want our contribution to cover our fixed costs, our contribution also has to make profit. And here we have a target profit. If we want to calculate now units required to achieve target profit, we're still using formula, but we're just going to change this to contribution per unit. So we take 24,000 plus 96,000, but now divided by 48. So we're taking 120,000 divided by 48. That gives us 2,500 units. So in order to achieve a target profit, we need to sell 2,500 units. Now how we could have done it is we could have just taken the 300,000 in revenue divided by the 120, would still have got the 2,500 units. Now we want to use this information for short-term decision making, because the key thing here is we want to make short-term decision making based on the information that we gather. So we calculated and noticed that our break-even point was equal to 500 units. Now units required to achieve target profit, we have calculated and noticed is 2,500 units. Now for decision making purposes, we understand that in order for the company to cover the cost, we have to sell 500 units. So the company has to have measures in place of how they plan to achieve the 500 units of sales. Then to achieve the target profit of 2.5, the company also needs to have a plan of how we're going to achieve the target profit. So either the company looks at, should we enter into a new market, or how can we get more customers to buy from us? Should we lower our price? What should happen? So now they have to play around with many management principles in order for them to sell the units required to achieve the target profit, as well as for them to sell the units required to break even. So here the key thing is we're not just calculating this, we have to use this for decision making. So we need to know who is going to be given this information. So as the management accountant, when you calculate this, you also have to give this information to the other relevant people and help in decision making. So this information can be passed to our sales force, our advertisement team, our marketing team, so that they understand that for the company to make the required profit, they have to sell 2,500 units. So anything less than this is not acceptable. Then we can also use this units required to achieve target profit as an incentive to say, by the time that you use 2,500 units, any unit that you sell thereafter, we're going to increase your commission. So now we're starting to apply decision making to our calculation. So that was our first example. Now we're going to look at another concept we call margin of safety. Now we're going to look at the concept called margin of safety. So the margin of safety, I'm going to first use an example before we explain it in words. So margin of safety. So for our syllabus, we can calculate our margin of safety in units, in dollars, or as a percentage. So margin of safety, to calculate it, we take our budgeted activity minus our break-even point activity. So it can be budgeted sales minus break-even point in sales. It can be budgeted units minus break-even point in units. That's one way of calculating it. So basically, if Your budgeted units, say for example, are 7,500 units. Then to break even, the company needs to sell 6,000 units. And we're saying our margin of safety will be 1,500 units. So that's the computative aspect. But now the question is, what does this mean in words? So what margin of safety means in words is, the company can miss their budget by 1,500 units before they start making any losses. So we're saying they have a margin of safety of 1,500 units. So I'll repeat that. Saying the company can miss their budget by 1,500 units before they start making a loss. Because our budget here is 7,500. We can miss it by 1,500, we'll still be at the break-even point. But if we miss it by more than 1,500 units, then the company is going to start making losses. So for decision making, this is very important to understand what is the margin of safety, because it gives us an indication of the riskiness of that product. So if your margin of safety, say here, was 4,000, so let's just give another example, 7,500. Then to break even, maybe we only wanted to sell 2,500. So therefore, it means that our margin of safety will be 4,000 units. So if we're going to look at those two companies here, let's call this company A, call this company B. Here, the margin of safety for company B is higher than for company A, which means company B is much safer than company A. So that therefore means company A is more risky than company B, because we can miss the budget by only 1.5 before we start making any losses. So it's very important to understand this concept and how it's used for decision making. We're saying by how much can we miss the budget before we start making losses. So the higher the amount, the greater the safety. The lower the amount, the higher the risk. So that's one way of calculating our margin of safety. But calculating our margin of safety in units here has one disadvantage. So we're going to explain the disadvantage using an example. So you have A, you have product A, you have product B, or company A and B. Then the budgeted units, 7.5. But for A, say it's 50,000 units. And the break-even point, it's 5,000 units. The break-even point is 47,500. Which means if we calculate our margin of safety using the first method, A is a margin of safety of 2,500, B is a margin of safety of 2,500. If you just given information that only has margin of safety, you're most likely going to say these companies are in the same position in terms of risk, because they all have the same margin of safety. But this is not true, because they have different budgeted units and different break-even points. So calculating the margin of safety in units or in revenue now has a disadvantage, because it doesn't give you a clear comparison without giving all the information. So in a case where you don't have all the information, it's hard to come up with a conclusion. So there's another way of calculating margin of safety that's better. We have to calculate margin of safety and then express it as a percentage. So what you do is, you take this margin of safety, express it as a percentage of the budget. So we say 2.5 divided by 7.5. Here we take 2.5 divided by 50,000. So 2.5 divided by 7.5, this gives us 33%. Then we need to know that 2.5 divided by 50,000 is only 5%. Now we can better explain our margin of safety. Because here what we're saying is, saying company A can miss their budget by 33% before they start making losses. But company B here can only miss their budget by 5% before they start making losses. Means company B is riskier compared to company A because they only have to miss their budget by 5%. So it's more likely to miss your budget by 5% than it is to miss your budget by 33%. So here we're making a comparison. Say company B is more riskier in comparison to company A. So calculating your margin of safety as a percentage expresses better the margin of safety. You give it as a percentage to say, by so much a percentage can we miss our budget. If we miss by more than this percentage, then we're going to have a loss. So this information also has to be communicated to the relevant people so that they know that they only have a certain margin of safety. They cannot miss the budget by any amount that is higher than the margin of safety. Therefore, it means that our margin of safety formula, which is basically it's your budgeted activity minus your break-even point activity, all divided by the budgeted activity multiplied by 100. That's how you express your margin of safety as a percentage. Then we're just going to use an example, the same example, example number 1 that we're looking at. Now, example number 1, we're going to look at requirement 2. Example number 1, requirement 2 says, what is the margin of safety for the next month? What is the margin of safety for the next month? So we want to calculate our margin of safety in units as well as a percentage. So say in margin of safety, it's our budgeted activity minus the break-even point activity. So our budgeted activity here, so budget sales for next month is 2,200. So we take 2,200 minus the break-even point of 500. Margin of safety will be 1,700 units. So that's margin of safety in units. So margin of safety in units is it's quite difficult to explain to someone because it's very relative. So if you get two companies that give you margin of safety in units, it's quite hard to explain, quite hard to differentiate between the two. But when you calculate margin of safety as a percentage, now it's easy to make your comparatives. So we take our budgeted activity minus break-even point divided by the budget. So we take 2.2 minus 500 divided by 2.2 times 100. So we take 1.7 divided by 2,200 times 100. So margin of safety is 77%. What this means is, for the company to make a loss, we have to miss the budget by more than 77%. So our margin of safety is very high. It's rare, or it's highly unlikely that we're going to miss our budget by 77%. So this company would consider it to be in a very safe position because their margin of safety is 77%. They have to miss their budget by more than 77% for them to make any loss. So that's the concept of margin of safety. Now we're going to look at our graphs. We're now going to look at the analysis of the graphs. So first graph that we're going to look at is called the break-even chart. So the other name is called the traditional break-even graph, the break-even chart. On our break-even chart here, on the y-axis, we have revenue or costs. Then on the independent axis, the x-axis, we have our units. So in the break-even chart, the first point that we need to understand, we need to identify here is this point. So at this point, our total costs are equal to our total revenue. Then this is our break-even point in units. And this will be our break-even point in dollars. Because on the y-axis we have our dollars. So when total costs are equal to total revenue, it's our break-even point. So that's the first point that we need to understand. Then the area that we have here, up to the break-even point, our total costs are higher than our total revenue. Means this whole area here, the company is making a loss because the costs are higher than the revenue. Then the moment that we get to a point where our costs are equal to our revenue, we get our break-even point. Then from the break-even point, going upwards, now the company is now generating profit because now its revenue is now higher than the cost. So we need to be able to identify the sections. So here, let me just label this A, just label this B, label this C. So these are very key things to know on a break-even chart. Then we can also include budgeted units here, so that this becomes our margin of safety. Remember, our margin of safety is our budgeted units less our break-even point. Said our margin of safety, we're just trying to identify by how many units do we need to miss our budget before we start making any losses. So that's just our basic break-even chart or traditional break-even chart. We need to know our break-even point, we need to know the loss-making area, we need to know the profit-making area. Then the difference between our total cost here and the fixed cost, it's our variable cost. Remember, our total cost is a component of fixed cost and variable cost. So here, from the fixed cost line, we superimpose a variable cost line. So we add variable cost to the fixed cost. That's how we get our total cost line. So we need to know the difference between total cost and the fixed cost. That's our variable cost. Okay. So that's it on our break-even chart. So we need to understand that with the break-even chart, there's one disadvantage. The disadvantage is on a break-even chart, we cannot easily identify contribution. Yes, we can get our contribution, but we cannot easily identify contribution. So we need another chart that helps us easily identify the contribution. Then another drawback here is in calculating our profit, it's a bit tricky to calculate the profit. So to calculate the profit for this whole area, we need to know the area that is shaded the same here. And to get our contribution per unit first, we need to get our variable cost. Because contribution, it's our total cost less our variable cost. So it has drawbacks. So those drawbacks are then dealt with the following graphs. The next graph that we're going to look at is a contribution chart or contribution graph. Our next graph is the contribution chart. Or contribution chart or contribution graph. Now, contribution chart, we need to first identify our break-even point. Our break-even point is a point where our fixed costs and variable costs are equal to the revenue. So our total costs are equal to the revenue. When the total cost line intersects with the total revenue line, so this will be our break-even point in units. And here we have our break-even point in dollars. So that's the first point to identify. Then we also need to share the loss-making area. So when our total costs are higher than our total revenue, the company will have a loss. Then when our total revenue is higher than the total cost, the company will generate a profit. Now the difference with the contribution chart and our break-even chart is, on our contribution chart, we don't have any fixed cost line. We do have a variable cost line. So it's easy to identify the contribution. Because remember, our contribution, it's revenue less variable cost. So it's easy to identify our contribution. And our variable cost line here and our total cost line, these lines are parallel. These lines will never meet. Because this variable cost line here, what we have just done is we have taken it and it started at the point that is equal to our fixed cost. Because remember, our total costs are variable cost plus fixed cost. So we just superimpose this line so that it starts at the point that is equal to our variable cost line. So those two lines will never meet. They are low, and their gradient is the variable cost per unit. So those two lines will never meet. So the difference between the total cost here and the variable cost is the fixed cost. Then if we have budget units, then we can also have our margin of safety. So in the exam, you should be able to differentiate between the contribution chart and the break-even chart. So the differentiator here is the contribution chart has a variable cost line. It does not have a fixed cost line. It has a variable cost line. So that's the difference between the two graphs. With the contribution chart, we can easily identify our contribution, because our contribution is total cost less our variable cost. And here we have a variable cost line. So that's our contribution chart. Now we're going to look at our last graph for individual products, the profit volume chart. Now our last graph for our individual products, it's a profit volume chart. So we call it the PV chart, the profit volume chart. So on a profit volume chart now, our y-axis changes. Our y-axis is either profit or loss. Our x-axis is the unit. So we call it the profit volume chart. We have our profits, we have our volumes. Now profit volume chart, it's very easy. It only has one line, but we need to fully understand it. It's one line. So the profit volume chart always starts with the loss. So let's say, for example, the loss is 20,000. Now the question is, why would a company start by making a loss? The answer then is, if a company does not sell any units, it still has to cover its fixed cost. So here our loss will be equal to the fixed cost. It means this company, the fixed costs are equal to $20,000. So if the company does not generate any revenue, we're saying if revenue minus total cost should be equal to 0. So that's how we break even. Our total revenue should be equal to our total cost. But we said if a company does not generate any revenue, if revenue is 0, the company will not have any variable cost. But the company now needs to cover its fixed cost. So if fixed costs are 20,000, and the company will have to generate a loss of $20,000. So the profit volume chart, it always starts here at the negative. And the loss is always equivalent to the fixed cost. Then we have the point where it cuts the horizontal axis, this point. So here we call it the horizontal axis or x-axis. At this point where it cuts the horizontal axis, this is our break-even point in units. Then here this is our vertical axis. So the point where this line cuts our vertical axis, it's our loss, which we can attribute to the fixed cost. So on this graph we need to understand that if a company does not sell any units, it's going to have a loss, it's going to make a loss. But then the more units that it produces or the more units that it sells, those units are going to be generating contribution, and the contribution will be used to cover the fixed cost. Once the fixed costs have been fully covered, the company breaks even. Then the company starts to make a profit. So what this means is the slope of this line is defined by the contribution per unit. The slope of this line is just an indication of the contribution per unit. So if the contribution per unit is higher, we would expect that would have a line like this. Let's call this A, let's call this B. The reason why B is slanting more to the y-axis, as we're saying, B is generating more contribution per unit. So therefore it covers the fixed cost much faster. So here, to just use numbers, we're saying here, a loss here, it's 20,000, that's the loss. Then if A is contributing maybe $50 per unit, then B is contributing $100 per unit. Mean that B is able to cover its fixed cost much faster. Because if we take 20,000 divided by 100, we get 200. But we take 20,000 divided by 50, and we get more than 200, so that will be 400. So it means B is able to cover its fixed cost faster because it's generating more contribution per unit. So how to just remember this in the exams? The steeper the slope, the higher the contribution per unit. The steeper the slope, the higher the contribution per unit. So the steeper the slope means the more the slope is slanting to the y-axis, the higher the contribution per unit. So just to put another line called C. Now we have three lines, we have A, B, and C. It means C here has the lowest contribution per unit because it takes time to cover the fixed cost. A is the second highest with the second highest contribution per unit. Then B is the one that has the highest contribution per unit because it manages to cover its fixed cost much faster. So therefore it has a higher contribution per unit. So the slope of the line here, or the gradient is an indication of the contribution per unit. So the steeper the slope, or the higher the gradient, the higher the contribution per unit. So it's able to cover the fixed cost much faster. So here it's easy to understand because the unit that we used here, or the product that we used, all had the same fixed cost. But let's just wrap this to just come up with another profit volume chart. So we can have product A, then we have B. So B is started maybe at minus $40,000. So if I'm to ask you which product here, A or B, has a higher contribution per unit, how you'd make the decision is you need to look at which product is slanting more to the y-axis. So you need to look at line A and compare it with line B to say which line here is slanting more to the y-axis. So here obviously the answer is B. Although if we look at the break-even point, A breaks even faster than B. But the reason why A breaks even faster than B is because A had a lower fixed cost. But then B breaks even later, but then it's able to exceed the profit of A. So here the most important thing is to look at the slope of the line. The steeper the slope, the higher the contribution per unit. So the more the line is slanting to the y-axis, the more it's slanting to the y-axis, it means the higher the contribution per unit. So that's a very, very important concept because the examiner can just give you 5 lines. Then you're asked to rank them in order of contribution per unit. Start with the highest, go to the lowest contribution per unit. So the key thing is to notice the steeper the slope, the higher the contribution per unit. So if we're going to rank them, B would be number 1, A would be number 2. So that's our profit volume chart for a single product. So this is the end of the single product break-even analysis. Now we're going to look at multi-product break-even analysis.